From the beautiful South Studios of Way Happy, this is Mr. Meyer and 8-3 hyperbolas. All right, hyperbola is going to feel a whole lot like an ellipse, right? And in fact, it's very, very similar. If you want, first off, the difference, remember that the two foci added together gave you a common sum that was an ellipse? Well, these two guys have a common difference, and that common difference is where all the points are for a hyperbola. Now it also has foci. In fact, I'm going to scroll down. I'm going to show you the graphs of what a hyperbola looks like right there and the equations, so you can decide if you want to sit and memorize all those again. But again, kind of the same rules. You will do just like before. You will pull off the center from right here. So the center is going to give you that. You're going to go in the y direction, whatever units, square root of whatever the denominator is. In the x direction, square root of whatever the denominator is. And then when you plot those points, you can kind of see in the drawings down below, you can kind of see that once you plot those points, you then make a box instead of your ellipse. That's where your big difference comes in. And that difference, is because there's a subtraction between the two. So then you will draw a box, and then you'll draw your asymptotes through those boxes so you know how wide to make your hyperbola. And then really the big key now is it open up and down or left and right? And that depends on which one's positive. If the x is positive, open it up in the x direction. If the y is positive, then go ahead and open this up in the y direction. Now, what do I mean by positive is, what variable is following the negative sign. If it's an x, then I want you to open these in the y direction. And if it's a y, I want you to open these in the x direction. I always think of the negative as not. So when I read it kind of left to right, I go that, like the first one here, this is not in the y direction. So don't graph it in the y direction. Make sure you graph it opening in the x direction. All right, best way to do this is probably to go ahead and talk about these things. There are the steps to graphing, but I'm just going to jump straight into graphing. But make sure you get it into standard form, which this one is. And then I'm going to go ahead and graph. First thing I'm going to do is just like an ellipse, I'm going to find the center. And so for us, the center is 0, 0, because there's nothing in parentheses there. So I'm going to go ahead and put the center. Beautiful. And then I notice here in the y direction, I'm going to go 4 units. So 1, 2, 3, 4, and 1, 2, 3, 4. And then in the x direction, you can see I'm going to go 6, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Totally feels like an ellipse right now. But because of the negative, that's the dead giveaway that it is a hyperbola. And so what does that mean? Instead of an ellipse, we're going to use those as midpoints, and we're going to make a box. So here's our box. Done. And then we're going to draw our asymptotes through that box. They're going to go through the corners and through the center. So through the corners and through the center of those. Now you should probably find the equation of those asymptotes, and it's really not a big deal. As long as you can remember y minus y1 equals mx minus x1. If you can remember that, point slope form, you're golden. Because you know a point, you always know this point right here is going to be the center because it went through the center. So the asymptote equation is going to be, for me, y minus 0 equals m x minus 0. Now, most people wouldn't put the zeros, so you can drop them, obviously. But what about the slope? Well, the slope's pretty easy to figure out, too, because you did it. You rose up this much, which to me looks like 4, and you ran this much, which was 6. Now, you did it positive, and believe it or not, you did it negative. So you want to talk for one line it's positive, one line it's negative. So what am I going to do? Rise over run was 4/6 or 2/3. So I'm going to put 2/3, but one was positive and one was negative. So there is your equation for your asymptotes. Clean it up, I guess. Y equals plus or minus 2/3 x. Those are the equations of the asymptotes. Just using a line. So I use the center, always use the center, and always count your rise over your run that you made for your box. Or if you want, look what's under the Y. We rose 4 and we ran 6 because it was under the X. So there it is. Now you just got to decide, are you opening this up in the X direction or the Y direction? So then you'll know which one of your vertices. Well, this says not in the X direction. So I'm going to open these up in the Y direction. So the blue part now that I'm graphing is the actual graph. Make it go out to those asymptotes. Start at that point, which is now the vertex. And there you go. So the vertices would be at, what was that, 0, 4 and 0, negative 4. And we don't call these things co-vertices, but I won't yell at you if you do. But they aren't really vertices. They aren't part of the graph. So they are just there to help you make your box. And so we don't call them covertices, but again, I won't yell at you if you do. There's your vertices. The foci. Oh, wow. I forgot to mention the foci. Remember my little triangle? Same thing here. Foci are going to be 16 plus 36 equals c squared. That distance to the foci from the center is going to be c. And that triangle, you just do the opposite between them. So what is the 40? 52 is c squared. So whatever the heck root 52 is. So I'd probably want to reduce that. Root 52 is that 4 times 13. So 2 root 13. So we're going to add 2 root 13 and subtract 2 root 13 from the center. So the foci are going to be at 0 comma 2 root 13 and 0 comma negative 2 root 13. And a little thing here you might want to notice is that the foci will be on the insides of these parabolas, just like regular parabolas, not like ellipses where they're in between. So that is how you graph them. All right, let me ask you a question and I'll be right back. All right, beautiful work. Now let's make sure you're not too scared here if I put a center in. So again, same exact stuff, right? So here is my graph paper. And I'm going to say the center is at, be careful, what is that, 3, negative 2. So 1, 2, 3, 1, 2. Boom, there's my center. And that's the first thing I'm going to graph. Then in the x direction, notice I went 5. So that's 3, 4, 5. Boom. And 1, 2, 3, 4, 5. Boom. In the y direction, I only go 2, 1, 2, and 1, 2. And now I'm good to make my box. So there is my box. And then I'm going to make my asymptotes going through the corners of the box and obviously through the center of the box. And now I'm going to find the asymptote equations. So I know it's y plus 2, just stealing the center, equals plus or minus the slope, x minus 3. Now let's figure out what the slope was. Well, it looks like we rose 2 and we ran 5. So it looks like the slope is 2/5, or you could have counted it on your graph. That is already reduced. And so there are the asymptotes. Piece of cake. Now I'm going to go ahead and finally graph this thing. Now the x is the positive one. I'm saying not the y direction. So let's make sure we open it in the x direction. So this is a vertex, and I'm going to open it up in the x direction. And this is a vertex, open it up in the x direction. Probably tell people what my vertices were. So where are those points? Well, what did I do? I added 5 to the y. To the x. So that would be 8, negative 2. And I subtracted it. So was that negative 2, negative 2? I just did that to the center right there. And last but not least, foci. Well, they're root 29. So c squared equals 29. So that is root 29. That doesn't reduce. So I'm going to take this center and I'm going to add root 29 to the x. So 3 plus root 29 comma negative 2 and 3 minus root 29 comma negative 2. It's a little more than 5. Remember, we went out 5, so foci are sitting right about here and here. Done. Don't scare me, right? Now, one thing I should probably mention is the line that connects vertex to vertex is called the transverse axis. So if you connect a vertex to a vertex, you're called a transverse axis. And if you, the one that does the covertices, which we don't really call covertices, but we'll call them here, that is called the conjugate axis. And the reason I say that is you're probably looking at the next example and you see that there's this thing called a transverse axis and a conjugate axis. So what is that telling me? Well, again, like anything else, I'm going to graph it. And I'm going to plot the point negative 2, negative 1. And I'm going to plot 8, negative 1. 1, 2, 3, 4, 5, 6, 7, 8. 8, negative 1. Now, why is that important? Because that is called the transverse axis, which means this graph looks like that, right? That's what it's telling me. It's also telling me that there's a conjugate axis of length 4. So that means going up and down. I'm sorry, up and down is length 8, or 4 above the center and 4 below. Now, where is that center? The center is like here-ish. Where is that? Well, again, I could use midpoint formula that says the center is going to be when you add the 2 points. So add the x's, you get 6, but cut it in half. And add the y's, you get negative 2 and cut it in half. So the center is going to be what? 3, negative 1. And that's about where I graphed it, 3, negative 1. So I'm feeling pretty good. So that's my center using midpoint formula. I'm trying to find the equation. I know that this way you went 4, this way you went 4, so that's good. And I know from the center that this was from 3 to 8. I know that this was 5 and this was 5. So I should be feeling pretty good. X has got to come first. So x minus 3 squared minus y plus 1 squared equals 1. And what's in the denominators? Well, in the x direction, we went 5. So I'm going to put 25. In the y direction, we went 4. So I'm going to put 16. And there is your equation. Done. So you can give me anything you want. And if you wanted to find the foci, you'd add those two numbers together, square root 41, and you can plot that. So with that being said, there is also eccentricity for hyperbolas. Again, it's also c over a, same thing as ellipses. Remember, c is the distance to the focus, and a is the distance to the vertex. So these numbers are actually going to be bigger than 1. In ellipses, they were smaller than 1 because the distance to the focus was smaller than the distance to the vertex. Well, now you got the distances bigger. So these are all going to be bigger than 1. That's how, if you know eccentricity is bigger than 1, you know it's a hyperbola. So that's why eccentricity is kind of cool. All right, that's it. Have a great day. Stay happy, and I'll see you tomorrow.